Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video we are going to solve this problem. This is a problem that relate the gas with the Dalton's law, and it is an example of water displacement method. So let's read the question together. A sample of silver oxide decomposed upon heating and the oxygen gas was collected by displacement of water at 25 degrees Celsius. The pressure collected is 750 millimeter mercury. Okay, the equation for the reaction is already given. So A, calculate the number of mole silver oxide decomposed. So how to calculate the number of mole? So for A, we are given the mass of silver oxide. So to calculate the number of mole, mole is equal to mass over molar mass. So the mass is already given, which is 1.650 gram, and the molar mass for silver oxide is 231.8 gram per mole. So it will become 7.12 10 to the power of -3 mole. Okay, ataupun 7.118. Okay, if you consider the significant figure, maybe I can put okay. So this is for A. Okay. For B, calculate the number of mole oxygen gas produced. So based on a balanced chemical equation, how we relate the number of mole silver oxide with the oxygen produced. So first we need to write the balanced chemical equation. So we can rewrite an equation. Okay, so the number of mole silver oxide is already calculated before. So we can write the statement 2 mole equivalent to 1 mole oxygen. If we have means that so the number of mole oxygen gas that we have is this is the answer for B. Now let's look at C. Determine the partial pressure of oxygen gas produced. Okay, so the oxygen gas is collected over water. The information that we have is P, which is 750. The temperature is 225 degrees Celsius, and it is collected by displacement of water. So we can illustrate the process. So this is the process. Let's see, we decompose of the silver oxide, or we burn the silver oxide, and the gas collected over water okay. If the gas produced from the decomposition will pass through a delivery tube, and it will collected here at this area. When we measure the pressure here, we can find the pressure is equal to 750 millimeter mercury. Yes. Okay, so the pressure that we record represent the pressure produced from the decomposition of silver oxide. So the P total is equal to P oxygen that produced from the decomposition, and also a water vapor, because it is through a water displacement method. Alright, if we have the P total, can we calculate the P oxygen gas? So the P total minus P water vapor. How to get the vapor pressure of water at 35 degrees Celsius? Okay, the value is already given in the question, or in the exam booklet, or at the back of your tutorial book. So the P total is 750 millimeter mercury, and the P water vapor at 25 degrees Celsius is 23.76. So that we can get the P oxygen (726.24 millimeter mercury. The vapor pressure of water is depend on the temperature. If the reaction occurs at 25 degrees Celsius, this is the value. Okay, so normally it is given in a question or given in an appendix list during the exam. Alright, do we need to convert the pressure to ATM? You can give the answer in millimeter mercury or ATM, depends, because the question is open. You just mention the pressure of water. Okay, the question does not specifically request for any figure, for any units. Alright, so next we look at D. Calculate the volume of the oxygen gas in liter. So in this case, it required in liter. Alright, so we already have the pressure, so that we can apply the PV is equal to nRT. P oxygen V is equal to N oxygen RT. We are looking for V, N oxygen RT over V. Actually, we already have the number of mole oxygen based on our calculation, which is 3.559 10 to the power of negative 3. R is a gas constant. The temperature should be in Kelvin. If we have the temperature given in the question is 25. (298.15) and over pressure. The pressure must be in ATM. So we have 726.24 divided by 760. The answer is 0.091 liter. Okay, so I think that's all. Thank you very much.